So this is going to be a really short video. The reason I'm putting up the video, I'm not going to make you take notes on it. I'm not going to make you submit them online. But just in case you want to go back after our classroom discussion and view this, that's what this is for. So this is your basically it's called a regression line. Um, More or less, what it is the line of best fit for all the data. So think about, we have all this data, right? We have a bunch of a scatter plot, and we have a bunch of points on a graph. And what we're looking for is to draw a line that best fits that data. And the reason you would want that line is so that you can make future predictions, okay? Or maybe not even future predictions, but you can estimate from something that happens. So that's the whole point. That's why we want this regression line. So, for instance, let's say this is our scatter plot, and we have a bunch of points all over the place. Which one of these would be a line of best fit? You know, is this one best fit the points? Is this one? Which one is the best estimate for all these points? It's not something that you can usually visually just say, yep, this is the best one. You can get close to it, but it's not always, there's always disagreement because it's human nature. You kind of have your own bias for one reason or another, and so you may think it should be a line that hits the most points, or it should be a line where you have equal number of points on both sides, and that's just not the case. So what they do is they developed an equation that essentially will measure the distance. So if you take each point and draw a line straight down to the line, and you find the average of all those distances, which line would have the smallest average of all those distances? That's what this equation does, is it'll automatically, for us, it'll figure out which line would have the smallest average distance away from all points together. Okay? So here are your formulas. Again, not very nice formulas, not ones that look like they'd be especially fun to do, especially when you get into a large number of data points. The nice thing is, if you paid attention to our calculator when we calculated the R value, the correlation coefficient, you also noticed that it gave us an A and a B. Some calculators are different than others. So for this example on these notes, we're going to treat A as our y-intercept and B as the slope of the line. But I always want you to look at your calculator and see what form it's in. And they'll usually tell you, because they will have y equals a plus bx, or y equals ax plus b, or whatever. And if you remember correctly, or if you remember from algebra 2 and now way back even to algebra, whatever number goes with your x, that's your slope. The number that doesn't go with x, that's your y-intercept. Okay, so however your calculator has it, just make sure you pay special attention to that. So we're going to do something real quick. The formula we're not even going to worry about. This is an example on 10.4 that if you plugged all those numbers in and you calculated it, you would get the following. You would get a value for A, you'd get 0.396, and a value for B is 0.106. And to plug it into the formula, it would be y, this little dash we call prime. So y prime equals 0.396 plus 0.106x. Me personally, I do not care, and I almost prefer if you switch this and you write it in terms of the way that we're used to writing your y equals mx plus b form. It doesn't matter. It doesn't matter because obviously addition, it doesn't matter if you go, in what order you add numbers in, it's going to get the same answer. So the order is up to you. It doesn't change the line. It just makes sure that you understand whatever number's with the x, that's our slope, and whatever number is not, that's our y-intercept. And then what you would be able to do is you could make a t-chart and you could plug in values for x and you would get values for y, and you could therefore graph the line. Okay, so that is it. That is our linear regression line of best fit. You're going to do a few exercises with those, and make sure you write down any questions if you have a